This is Tech Days.
One moment. Ett magiskt ögonblick, livet, kan upplevas som små magiska ögonblick. Kanske är Power of Now möjligheten att sammanfoga de här magiska ögonblicken till en upplevelse av en enhet av något sätt som ligger fast klistrad på livets tråd. Kanske är det så. Välkommen till en magisk dag.
Hej och varmt välkomna till årets Tech Days, det 9:e i ordningen. Och vi är på väg att skriva historia, för det är rekord. Vi är över 2000 personer i den här salen. Det är helt fantastiskt! Jag heter Therese Treutiger och jag är vice vd på Microsoft Sverige. Min personliga relation till teknik, det tar sig några år bakåt i tiden och det börjar med mitt barnprogram Från A till Ö med Hedvig Höök. Hedvig Höök, hon fick inte bara en lång näsa när hon ljög, utan hon hade även en magisk bildtelefon. Och det är några år sedan, jag vet, men det har etsat sig fast i mitt hjärta och i mitt minne av tekniken som var för mig magisk.
Ja, jag heter Daniel Akinin och jag jobbar som nationell teknikchef för Microsoft Sverige. Jag skulle vilja fånga upp den här mobiltelefongrejen egentligen kring det här ämnet magi. För att jag minns själv faktiskt när jag kände ett sånt ögonblick. Och det var när jag ringde för många år sedan nu till en kompis. Och han svarade medan han var ute och gick på stan. Och jag kände verkligen då, wow. Det här är någonting som verkligen kommer att förändra både mitt liv, hans liv och våra liv. Vilket det också naturligtvis har gjort. Ett par år senare minns jag så åkte jag i tunnlarna med X2000 runt Södertälje i 150 km i timmen och ringde i samma mobiltelefon som jag då hade köpt. Och då bröt samtalet och jag minns jag tänkte, fixar de ingenting i det här landet egentligen? Och vad innebär det där? Ja, men det innebär att förväntningarna på teknik, de stiger ju hela tiden naturligtvis. Så någonting som vi plötsligt ser som magi kommer i nästa sekund vara någonting som vi upplever som ganska naturligt. Och det är bra, för det innebär att vi måste jobba i det här rummet för att uppnå de förväntningarna och hitta nya magiska ögonblick hela tiden.
Årets tema är The Future Computed. Det anspelar på en titel på en bok med samma tema. Och det är vår chefsjurist Brad Smith på Microsoft och även vår AI- och utvecklingschef Harry Shum som har skrivit den boken. Boken belyser flertalet teknologier som kommer påverka samhället. Så som vi lever och så som vi uppfattar det idag. Det är AI, det är quantum computing och det är mixed reality. Det är teman som kommer genomsyra de här 2 dagarna. Tekniken är inte bara en framtidsteknik utan tekniken är också här. Och tillämpningen av modern, förunderlig, fantastisk teknik, det skapar magi.
Ja, och programmet idag är verkligen otroligt spännande. Jag önskar att jag hade möjlighet att vara med på alla. Men jag tänker att det faktiskt börjar bli dags att komma igång med själva keynote-programmet. Och in order to do that, I'm going to switch over to English because our next speakers are from the US. And I'm very happy to introduce Lorraine Bardeen. Lorraine Bardeen is the general manager and responsible for the mixed reality workplace at Microsoft. She's the leader of a team of leading experts in technology innovation. And with her, she's going to bring Mark Griswold, who is the professor of radiology at the Case Western Reserve University. Welcome up on stage, Lorraine Bardeen.
Thank you so much for the warm welcome. I'm really happy to be here. It was great to get an invite to speak at Tech Days this year. I'm able to come to this area of the world maybe once a year at least to visit my team who are up in Linköping, Sweden, that's Simply Gone, who are working all day long to make the 3D asset pipeline better so that we can do a lot more with mixed reality. And I'll say that every time I show up in Sweden, they're kind enough to introduce me to new amazing food, which is now very important to me. So this time, the most amazing, best food I've ever heard of is kallis. Is that right? Kallis. I didn't know that you could carry a tube of fish paste around everywhere with you. It's so wonderful. I plan to buy a whole cupboard full before I go home. So anyway, thank you for the welcome. Now, today, I'm going to talk about IoT and mixed reality and AI. And the way I'm going to talk about it is by really referring to this change that's happening in how we build apps and experiences. Now, my team is responsible for building apps and experiences for our customers. And this is really the first time ever that because of a lot of changes in technology, we are able to build these apps for the world as a computer instead of for a PC as a computer or a phone as a computer. And that means thinking very differently about the computer that we're building for. This is the real world. And it means we need different tools to build for that computer. And that's what I'm going to talk about today. Now, whenever I talk about amazing new technologies and what they enable us to do, I always want to start with the human motivation behind these changes. Because if we really understand what people are trying to do, it makes us much more effective as technologists in delivering the right things for those people, because people's motivations, as you know, are behind the decisions we make. So let's talk about what's changing in how humans interact with information and what they're looking for. Well, first of all, we know we are naturally driven to collect information, to share information with each other, to learn from other people. We are biologically drawn to understand our world and to use that understanding to make better decisions. And we are instinctively driven to evolve how we use and share information. There are a couple things that I like to refer to when I think about how is information gathering and sharing changed. There's been a big change in the quantity of information that we can exchange. That's obvious. There's been a big change in the speed with which we can access information and share it. There's been massive changes in the reach. One single data point or one single insight can now reach billions of people in a very short amount of time. And this one is the one I'm the most passionate about right now. There's a very recent change in how relevant the context, where that information was generated, the context of information and your ability to use that as a technologist in providing solutions for people, that's a huge change. So let me just prove this to you by looking at, information sharing since the dawn of time. So this is all time eternal, related to human history. Now, if you think about gathering around the campfire, people could talk one-to-one and exchange ideas, right? And then some clever person thought it would be very useful to write down this information. And what that does is it expands the reach of that information. Then we started storing them so that it was faster and easier to exchange that information with other people. Another major accelerant in how information could be shared between people. And then, the internet. Whatever, slight change in the speed and access of how people could share and learn from information. Now, these are, as you know, radical changes in our ability to connect each other and learn from each other, which is a core human motivation. But then, with smartphones, we talk a lot about how mobility has changed so many things, but what I want to call out today is this one point where, for the first time, where that data is gathered is a huge determinant in the value of the experience you can have. So the simplest, obvious example is try to imagine yourself navigating an unfamiliar area right now without GPS anymore. I'm sure many of you can do it, but we rely on the fact that our data sets understand where we are and can help us navigate from that place to another. This is obviously what enables great applications like ride-sharing apps and things like that. But introducing the context of information is a major building block for apps and experiences to be built on top of. This is what is enabling us to think of the world for the first time as a computer that we can build for. And then the way I think of IoT data signals is now for the first time the world itself is providing data from which we can learn and make decisions. And so it's both inside out, the humans producing information, but also the world instrumented through IoT devices is starting to generate data upon which we can build information and applications and experiences. Okay, so what does that mean? That means that today we really can function with the world as a computer with input, with output, with processing power that we can build for. This entire world of information is available. And so then it starts the question, how do we navigate this? I'm sure you've heard from many of the people you work with, maybe you face this in your own jobs. Just because there's a lot of information out there doesn't mean we have the tools we need to navigate it and to build upon. So one thing I recommend doing, and that we do in our organization, is take everything we've learned from navigating the digital-only world and apply that to the physical plus digital computer that we're now confronted with and have the opportunity to work with. So in the digital world, we're used to measuring data, taking some action on that data, and then wherever we can, use AI to automate and remove the more mundane data processing, and then measure more, and then act on that, and then automate what we can. We're used to that framework, and that makes a lot of sense. So how does that apply to the physical world? How can we see that playing out? Well, let's just take a very simple example of traffic congestion, which is a huge problem in Seattle, where I live. Maybe a problem here, I'm not sure. So you can measure, you can use IoT devices, instrument in the world, of course, to measure where you're having the biggest problems with congestion. You use that information, those signals, to then act and make some changes. And in this case, you can see that you need people to be making that decision. That's important when you're first making insight-driven, world-based decisions. But then, as soon as you can, take the opportunity to build in artificial intelligence systems and machine learning so that you can then automate the learning based on the signals in the real world. And so when this works great, you have a previously congested traffic area that flows smoothly. When it works horrible, you have to go back and figure out what you did wrong, either in your AI model or in the decision point where we're getting humans engaged, because we don't always make the best decisions. And so I think of IoT, collecting the data in the real world and measuring, mixed reality, giving a new first-person point of view, a human-based point of view on the world, bringing digital content right into the real world, and then AI enabling us to automate many of those processes and insights. I think of these as tools that we can now use to navigate this world as a computer. So for the rest of the talk, I wanted to give you just specific examples of how we personally, and then how we see customers and partners we work with using IoT, mixed reality, and AI as tools to navigate this world as a computer. And then in a few minutes, I'll welcome Mark Griswold, who you heard about already, who's applying these same concepts in the classroom and how we teach students and train medical professionals. So let's start with IoT. So one of the things that we've focused on, because my team has been building applications and experiences that run on top of the world as a computer for a while. And we try to take the simplest possible approach to start. Because when you're making new applications for a new computing platform, there's a million things you can do. So we try to take the simplest and highest value approach. And with IoT, what we found is we can provide a lot of value to our customers in manufacturing, in retail, and warehousing, and commercial industries by just listening and just providing counting and sensing. Sensing IoT devices can make a huge difference in the effectiveness of businesses, because it turns out humans have amazing 5 senses or more, but it doesn't mean we're great at counting or we're not that good at hearing. And wherever we can offload some of that work and open up humans to do like the really high-value decision-making that we want to do in our workflow. And so we think about cameras that enable seeing and counting, IoT audio devices that enable listening for anomalies that are happening maybe on the work floor. And then simple touch-based input that can act as sort of a member of the team in automating workflows. So I'm going to show you an example of one of our customers, ThyssenKrupp Aerospace, who have deployed really simple sensors that are transforming their ability to manufacture products and to serve their customers.
At ThyssenKrupp Aerospace, we partner with the world's leading aerospace companies to simplify their supply chain management. We have a complex flow of materials in our factory to keep production running smoothly.
Our top priority is keeping people safe and making sure they have access to all the tools and information they need to make better decisions quickly.
Microsoft's mixed reality tools are helping us get there. As we take on new projects, we need to optimize our workflows. With Microsoft Layout, we're able to make design changes in our actual factory space with 3D holograms.
Once we have an optimized workflow, we use spatial analytics to help drive quality improvements. We're running 24/7 on most saws, so it's expensive to take one offline. Spatial analytics listens to our machines and helps to tell us the right time to replace a saw blade, balancing quality with the bottom line. One of the most stressful things in our business is when a customer calls to tell us they have a grounded plane waiting for a part. We have to drop everything and get that part out so the plane can get flying again. We need to move fast since it affects all of the other orders in our pipeline.
Cortana, what 14-foot saws are available?
Cell 14D is available.
Cortana, tell planning that I'm moving to cell 14D.
Integration with Teams and Cortana allows our workers to make quick, in-context decisions that speed up production. No matter how fast we're moving, we need to deliver the highest quality products every single time. When we finish an order, it's important to document the condition it was shipped in.
Spatial Analytics helps us with the quality assurance process. We can store time-stamped information and photos about our work orders for future reference. With Microsoft's mixed reality tools, we're able to work faster, safer, and at a higher quality than ever before. We can't wait to scale this across our entire organization. There's so much possibility.
Now, one of the things we learned from working with ThyssenKrupp on this project is tracking the anomaly, the sounds that the machines are making, and knowing when to replace a saw blade. That's the scenario that they had in mind going in. Once they learned about the possibility with machine learning and AI models on the edge, right, instrumented into their work area. But to be honest, once they ran the proof of concept, they realized there was even higher value use case for them just tracking whether the machine was on or off using noise. And you can imagine that's actually a relatively easy AI model to build compared to anomaly tracking for the sound of the saw. And so the reason I tell this story is I can't really emphasize enough how much opportunity there is for you to use your existing skill sets and start to bring that to this world-based computer. It's very similar to, you know, the immense value that the first mathematical calculations, being able to do that on a computer, it was maybe a very simple thing, and that's where we are with this world-based computer. The simplest workflow improvements can bring companies immense value. So I'd encourage you to look for these really simple use cases. There are a lot of tools out there that already enable us to be successful in helping our customers. Now, talking about mixed reality, we had the opportunity to bring to market the HoloLens from Microsoft several years ago. And it's an incredible gift to be able to work with the HoloLens and with our customers who are experimenting across all sorts of industries and use cases, because this is the world's first untethered head-worn holographic computer. It enables you to bring any of your digital content right into the real world and work with it like it's a normal object or application or experience right in the real world. And as you can imagine, for people who work in trades and in industries where they need their hands free to do their best work, they haven't been able to use the power of computing at all during their core part of their workday. So for the first time, they're able to bring in information, contacts, collaborate with someone else, and bring that information in context, like we were talking about earlier in the presentation. One of the ways I sometimes think about this, if you imagine this landscape of the world with all these signals and information flowing, whether you're on a factory floor or anywhere else, sometimes I think about the person wearing the HoloLens as sort of, see that little path? It's a first-person point of view actor. This is the person who can move through this world and act and make decisions. And they always have this first-person point of view visualization ability to see the data, see what's happening around them. And it's really the collaboration of these two world-based signals together with first-person point of view decision ability that enables this world-based computer model that I've been talking about. So let's take a look at another example from another customer of ours, Chevron. And Chevron has a really complex workflow where they have incredibly expensive, complex machinery really far away from the experts. And so they're constantly struggling with how do they solve problems when whoever you need is nowhere near at hand. And then if you need to fix something, you can't just prop up a YouTube video and hope for the best. You really need high-level expertise, real-time, right in your work area. So let's take a look at how they're using mixed reality and this world-based computer concept to solve their workflows.
Chevron's journey with innovation has been going on for over 100 years. What Chevron is looking for in new technologies is basically technologies that are different. They bring a lot of value into the company, that increase our safety within the company, and bring financial savings to us.
We have to have reliable and incident-free operation because that's when the refinery's up and most stable and in its safest mode.
Even a second of downtime is significant given the volume and scale that these facilities operate on.
The refinery itself is a set of hardware. Really what makes the difference in a performance and utilization space is how our people interact with that hardware, and that's where technology comes in.
Being able to use technology to improve our communication makes our lives more efficient and allows us to spend our time on more value-added work.
When we first saw the HoloLens, this was just a transformational technology. This is a technology that is going to take us to kind of the next level of digitization. Chevron uses Dynamics 365 Remote Assist for two core scenarios. The first one being Remote Expert, where we put any expert anywhere in the world in under a minute. And the other one being Remote Inspection, where we allow our inspectors to inspect the construction and the operations of our facility in real time. We have facilities all over the globe. We have facilities in areas that we can't get to all the time. So being able to digitally transform that expert into the field within a minute or so is foundational and just transformative.
This saves our engineers and our folks tons of time in how they go about doing their normal work every single day. That's a tremendous reduction in operating expense for us as a refinery, but also it makes their job a whole lot easier.
It's critical that the team's able to innovate and change. That's really what gives us the competitive advantage against other refineries.
Out-of-box solutions are important to Chevron because we simply don't have the expertise to build those solutions and maintain them long-term. We're not a software company. We're not going to do it as well as a Microsoft would, and it's just not cost-efficient for us in the long term. We've acquired over 100 HoloLenses. It's another device just like our laptops and our phones, and we hope to get to thousands of HoloLenses. From a Chevron perspective, the HoloLens is just a brand new technology that's enabling us to do things that we couldn't do in the past.
So you can see the point I was making there, that they think of their plant and the refinery as a machine, or as I was saying, as a potential computer. But they need tools to access that and to draw the information and the people together to make better decisions real time. And that's what they're able to do with this combination of the IoT devices they already have instrumented throughout their plant, but then for the first time bringing new visualization and communication capabilities to their workers as they move through that world-based computer using mixed reality in the HoloLens. And then finally, the point I wanted to make on how AI ties this together is really a very small one. I have the opportunity to work with some of the leading AI experts in the world, both at Microsoft and elsewhere. And I'm making a very small point compared to the things that they're working on, which is often the power and the breakthrough potential of AI starts with very small, useful things. Small, little useful things. And that's what we're seeing happening in this world-based computer. So I have a picture of a very small, useful thing. All this is a microarray in a little plastic box. And the AI, excuse me, the AI model, as I said, first we built a relatively simple, but it took a while to tag the data and to make a strong machine learning model that would identify audio anomalies in the saw blades. And each one has to be custom built. But AI and ML on the edge is a massive part of how we're going to compute going forward. That said, the simple on or off, is the machine on or off, is already transformative for the company. Because that means they can reduce the number of rounds the person has to make just checking, and that person can be doing higher value work that's more empowering for them and higher value for the company. So my point on AI in this talk was really just don't eliminate or ignore those tiny little useful things that start to connect and enable your customers and partners to make quick decisions that just smooth out the workflow. That's where I think a lot of AI will bring value into this world-based computing. So overall, What I wanted you to walk away from is there's a huge amount of potential for all of us across the technology industry, regardless of our roles, in starting to build applications and experiences and workflows and services that empower people and that take advantage of this new computing platform that we all have, which is all around us. And I think we have the tools now to really start to make progress in doing this. And then, because no talk is complete without really thinking about how are we educating the technologists of tomorrow, the medical practitioners, the doctors, the physicists, et cetera, I asked my very good friend, Dr. Mark Griswold, if he would join me, and he's going to share with you how he's incorporating these concepts into the classroom, into the medical school, and into many different industries, as you'll see towards the end of his talk. So Mark, welcome.
Thanks, Lorraine. Hi, everybody. Good morning. It's really great to be here. I really enjoy Stockholm. It's really a beautiful city. As Lorraine said, I'm going to talk about how we're looking at this concept of the world as a computer. And at our university, and specifically the institute that I direct, the Interactive Commons, we're trying to understand how this technology affects what we teach our students, how they're learning, and how that's all going to impact the jobs that they're going to move into in the future. I'm not that old, but this stuff is happening really fast. This is the way that I learned and found information when I was in college, and I assume that many of you did as well. But the students who are showing up at our university now have never been alive without Google. And not only that, they're carrying around all of human knowledge in their pockets. And they're constantly connected. And so we really have to ask, how does this world affect what we're teaching the students and how they're learning and what those jobs are going to look like in the future? We love stories like this. So this is a story from America where an 8-year-old kid learned how to drive on YouTube, got hungry, put his 4-year-old sister in the back and drove to McDonald's. And the only reason he got caught is because his parents' friends were at the same McDonald's. So that kid is 8 today. He's going to be ready to go to university in 10 years. But are we going to be ready for him? Are we going to put him in the same classroom that we've had for the last 100 years, which looks like this? I don't think so, because that educational system was meant for a different set of jobs that looked much more like this. Factory workers, line workers, office workers. This is not what the job of the future looks like, as Lorraine said. It may seem like anarchy to suggest this, but in the world that we're moving into, do we need to teach students long division anymore? You know, when I can pull this up on my phone or ask Cortana, do I need to do that anymore? When my phone can measure everything in the real world, do I need to teach students geometry at the same level that I did before? All of this may seem radical, but I would argue that the elders that came before us probably thought it was radical to move from navigating from the stars to navigating with a paper map. And now we don't even do that. We do this all on our phones as well. So if that's the world that we're moving into, then we think the classroom should start to look like that as well. So instead of having students memorize a lot of facts, we should be teaching them how to find facts, how to assess the sources that are there, and how to assemble that into information that they can communicate to others. And so if that's the job of the future, then our classroom should start to look like this as well. And this concept of the world as a computer is one way that we can do that. At our university, we had the opportunity to really dive into this deeply. This is the new health education campus that we're building with Cleveland Clinic. This is a 50,000 square meter building, so it's like a football stadium in a way, where all of our medical students, dental students, nursing students, and physician assistants are going to be trained. They're going to be trained in interpersonal education, so to be able to work as a team from the beginning. This building has every kind of technology that you can imagine in it, except for one thing. It doesn't have a cadaver lab that you use to teach anatomy. This will be taught completely digitally. So to say that that was radical would be an understatement. If you think about it, the way we've taught every physician for hundreds of years is based on cadaver dissection. And our university gave our team 4 years to figure out how to do it a different way. But if you fully accept this concept of the world as a computer, it actually is not too hard. So our classroom now starts to look like this. So we have an anatomical model that's in the center of a group of students, and we're up and engaged and learning in a completely a new and engaging way. So for the last 4 years, we've been working to develop an anatomy curriculum based on this. And we've done over 20 trials now trying to see whether we can teach and whether our students are performing as well as with the conventional kind of cadaver situation. And what we've seen is that it's very positive. And I'm going to just show you some results from one rather large trial that we did of 64 students. So we took some students and they learned the anatomy of the arm in the cadaver lab, and then they went and they learned the anatomy of the leg in the HoloLens lab. And then we had another group where they switched. We had a third group that never used HoloLens. And then all on the same day, just about a year ago, we tested them all. And the nice thing is that we saw no difference in the scores. And I want to note that this was a real test. So the students got whatever their best score was on those two tests, whether HoloLens and the cadaver lab, but this was a real test. So this already showed that we could teach at the same level using mixed reality as we can in the cadaver lab. But what was even more interesting to us is the time. So we were able to record every second that a student was in HoloLens, and what we saw was that they spent an average of about 3.6 hours learning in HoloLens compared to 6 hours they spent in the cadaver lab. And that's just the in-class time. So that's a 60% reduction in time for the same scores. But it could be even better than that. We only got about half of the data back on how much time students were spending outside of class. But the ones who returned their surveys averaged 11 hours outside of class. And we know that this is probably about right because this is a difficult topic. So that could be as much as 1/5 of the total time almost. So this ability to teach in mixed reality has allowed us to very quickly teach students their important information that they know for their future. And what this has allowed us to do is to bring new things into the curriculum that they wouldn't have exposure to otherwise. So our full anatomy curriculum is now divided up into 3. The students are going to learn the basic structures in holoanatomy, so in mixed reality, but then they're also learning using physical diagnosis and ultrasound and radiology. Neither of these last 2 groups are typically taught to first and second year medical students because there simply wasn't enough time. But now we can add this to the curriculum, and what this does is it gives us the ability to have them interact with living patients, real diseases in radiology. And so we call this curriculum now living anatomy, where before it was gross anatomy. And I find this to be much more compelling because I care about my doctor treating me while I'm alive. And I hope that you all agree with that. And so this ability, or this decision to adapt mixed reality has allowed us to do new things. And we're looking at doing this across the board. One of them is that when the world is a computer, I can essentially transmit myself to the other side of the planet and feel like I'm present. So this is 3 students working together on an anatomy model at 3 different locations. And so they're able to talk to each other and interact with each other as if they're in the same physical location. And so now our classroom is not just limited to Cleveland, now it could be truly global. So we think this is going to change everything, or many of the ways that we interact as humans. So now when these students go out into the world, they've got this superpower of mixed reality and the world as a computer. They're not going to just go back to the old world either. This is going to go out and this is going to impact almost every corner of medicine that we can imagine. And I could spend hours just talking about every one of them. I'm just going to talk about one small corner to give you an idea of the practical impact of that. And that's just the hospital patient room, which unfortunately almost every one of us is going to have to experience either by ourselves or with a relative. And these can be kind of scary places to go. There's a lot of equipment around that makes a lot of noise, a lot of displays that, are showing your health information. Nurses are constantly coming in and out to check everything. And so it can be a somewhat stressful place, not necessarily the healing place that we would like it to be. But when you think about all of these displays, there are almost none for the patient themselves. Almost all of this is information for the staff. And so why are we displaying this in the room for them? We could imagine a world where we take all of these devices and all of these flows of information. These become secure IoT devices, and all of that data then is displayed to the staff through mixed reality or some similar technology, so that it's displayed to the people who count in this case. In the back end, then we can support all of these data streams with artificial intelligence to make sure, just like Lorraine was talking about sensing anomalies in a factory, we can do the same thing to make sure that we're monitoring this patient constantly and providing a much more comprehensive picture of this person's health. And so what this means is that the hospital room becomes much more comfortable, hopefully much more healing. All of those distracting devices go away, and hopefully this is a place where these patients can get better faster and hopefully have a better outcome. But as I said, we think that this is going to impact almost every part of a hospital, from the way that we collect medical images to the way that we do surgical planning, the way that we educate patients, and then even inside the operating room as we're doing surgeries, we have a very high quality guide as to what the surgeon should do. So as I said, this is going to impact every area of medicine in the next few years. And we see this impacting every corner of our campus, whether it's physics in this case, material science. We're working very heavily in art history. And actually last year we did the first holographic dance performance that's actually being repeated again in 2 weeks. So it's essentially allowed us to create a new art form. So when the world is a computer, you see things differently. And one of the reasons that I am here is that I'm excited about what you all will see. Because as Lorraine said, this is going to impact every industry, from pure industrial applications, commercial, retail, on my end, the education and healthcare. So I'm really excited to see what you guys come up with. Thank you very much for being here today.
otroligt måste jag säga. Jag kan garantera att det där är ingen trickfilmning alls inblandad. I'm going to switch over to English again. Because what we are going to do is going to move from the really big things over to the really small things, where basically common sense makes no sense, and the Schrödinger equation is kind of the king. So we're going to talk about quantum computing, we're going to talk about quantum mechanics. And by doing that, I'm so happy to be able to introduce Professor Charles Marcus, who is the director of Microsoft Quantum Lab in Copenhagen. Welcome, Charles Marcus.
Thank you. It's a pleasure to be here, though I have the assignment of trying to teach a lesson in quantum mechanics to a group this big. And you might not have even liked quantum mechanics the first time you took it in a smaller environment. So it's a big task, and I'll try to cover some highlights of, in particular, focusing on Microsoft's activity within the realm of quantum computing. Before we take on a problem this hard, let's feel good about a success story. These pictures illustrate a success story. In one lifetime, we went from the invention of a technology, the use of semiconductors, a material that can turn on and off in the presence of a voltage, to everything that brought us here together. We manufacture on the order of 10 billion transistors every second. And if you were wondering when nanotechnology was going to happen, it happened. It's right there. So we have a technology which is remarkable, transformative, and growing every day. This is a Microsoft data center. But I want to go beyond this technology, which, as we've seen already today, has a pretty far-reaching frontier. And the place that I want to start with the motivation to go beyond this technology is underneath this data center. This is just a view of the basement of the data center. And mostly what you see in the basement is pipes filled with water. These data centers are gigantic energy hogs, and we are paying for the graphics and the technology and the Cortana. We're paying, our children are paying. The carbon footprint of the world's data centers exceeds the airline industry. So these are massive energy eaters. They're expensive, and still they're limited, and there are a lot of problems that we just can't solve. So I want to take a fresh cut at the problem, not by pushing that frontier from the 14 nanometer node to the 10 nanometer node to the 7 nanometer node, not that way. I want to do it by going all the way back to the roots of the subject of 20th century physics, quantum physics, that describes the world we live in. And ask the question, you can see from this picture of Bohr and Einstein that they're obviously bothered by something. And I want to ask the question, what were they bothered by? This is what bothered them. It's not magic. Nothing that I'm going to say is magic. Nothing that I say is controversial or subject to debate among scientists. And nothing is more complicated than a drop of oil on the surface of water, where the colors indicate that there has been an interference phenomenon. The two waves of light bouncing off the surface have interfered with each other. The two waves that have gone via different paths. If you remember studying this in school, one bounced off the surface, one went down to the bottom of the oil droplet, and they interfered with each other. Waves do that. Waves interfere. If I put my finger in a pile of water and I make waves, the waves will have places where the amplitudes add and double, and they'll have other places where they cancel out and disappear. Now, this phenomenon is not like the rest of the world that we experience, except in these domains where there are waves, like ocean waves. But, you know, I live in Copenhagen. There's a lot of bicycles, just as there are here. And it has never been the case that when two bicycles cross the intersection and are at the same place at the same time, that the maximum of one and the minimum of the other cancel out, and the two bicycle riders go right through each other. I can tell you from personal experience, that's not what happens. And so you can ask, what's the difference between the way we on a bicycle behave and how waves behave? And where this becomes difficult, and where it becomes the problem that Bohr and Einstein were so troubled by, is when you let the light or electrons or any other particle that has wave properties impinge very slowly on an interference pattern, the pattern of colors or the pattern of stripes that indicate interference. And then something very upsetting happens. And I don't need to give a whole lesson for a whole year in quantum physics, because all of the strangeness of quantum mechanics is right here on these pictures. I let the light or the electrons go through two slits, they land on the screen, and they form discrete events. You can see the discrete events. They're those green dots on the screen. That's when each particle of light or particle of electricity hit the screen. Now, if I asked you the question, where was that particle of light? Well, you'd know the answer. If I pointed to one green one, you'd say, it was right there. That's where it was when it hit the screen. But if I let the pattern evolve and you see the interference pattern once I let many go through, and then I ask, no, where was it before it hit the screen? Where was it on its excursion to the screen? You might say, I don't know, because I didn't measure it there. But the fact that it forms an interference pattern means that that can't be the right answer. The only answer that you could come up with is, it must have been everywhere. It must have gone through both slits before it landed on the screen and made a single spot and became one object. Before that, it wasn't one object. Now, after a while, particularly if you're a physics professor, you say it enough times over enough years, you get kind of used to it, and it stops bothering you. But if you go out and you look at the night sky, and you look at a star, and you realize that the light has come from thousands of years, maybe millions of years from the star to your eye, and before it got to your eye and was measured to be there in your eye, where was it? It must be the same story. It must be that it wasn't anywhere. It wasn't anywhere until it got to your eye. In fact, you could say that it was just as likely to have been on the far side of the star, going the other direction towards some other planet. But then suddenly, it was in your eye. And then the probability that it went the other way suddenly becomes 0. It could have gone the other direction, and the probability that it did go the other direction was non-zero until your eye told it where it was and made it there. And how long did it take for the information to get from your eye, which made the photon there, to the far side of the star, a million light years away, saying, you're not there anymore. You're here. How long does it take? It's instantaneous. Now you know at least why Einstein was bothered. But over the years, we've done these experiments over and over and over again, and there are people who, I mean, I wouldn't do it because I think it's Maybe once you see how strange it is, you kind of get over it. But there are people who have dedicated their careers to the idea of testing and refining these questions of, can you make a correlation which is, as they say, non-causally separated, and have the correlation be real? It isn't that this one caused that, but the correlations exist. What Einstein called spooky action at a distance in his writing. And over and over and over and over again, that's the way the experiments come out. So we can stop asking ourselves, is it true? And we might ask ourselves, why am I so bothered by it? Why did my brain evolve to not be able to grasp that in an intuitive way? But that's a biology question. That's about our brains. The experimental facts are in, and they're uncontrovertible. So now imagine a different kind of problem. Imagine that the state of a transistor being on or off is determined, and that lets electricity flow to some other transistor, which then turns on or off. But what if the state of the transistor is unmeasured? What if nobody knows whether it's on or off? Or, like the light, it was both at a time. The light didn't have a location, the transistor doesn't have a state. Well, then the transistor can be on and off at the same time, which can both simultaneously turn on and off another transistor, which can then simultaneously turn on and off another transistor. And then you suddenly go back to the very first one and you measure it. And that determines what the other states are all around the chip. And what's the time delay before those correlations exist? 0. What I've told you are scientific facts. The probability that someone's going to do an experiment and we're going to have to revise the last 60 years of textbooks saying, oops, everything we thought about quantum mechanics was wrong, is essentially 0. But interestingly, these facts have never been used in any technology that we've ever produced. They're subtle, they're a little hard to work with, and they're untapped. Let me tell you about 2 problems that could take advantage of this set of facts, where the computation power of the world is not sufficient. Here's one. It's a little problem that might not seem so appealing or so sexy. Fertilizer. Fertilizer consumes more than a percentage of all of our energy expenditure, and if you really want to save lives, worry about fertilizer. Fertilizer happens automatically in plants. Plants take nitrogen out of the air and they fix it and they produce ammonia. And they do it using a bacterium that I've shown at the bottom of the screen. And that bacterium uses a molecule, protein, that looks like what I've shown. And inside of that is this funny little complex. And I say funny because who would have thought that the entire world of plant biology required this complex with iron atoms and then molybdenum atoms? And it's true, it needs it. It needs this complex in order to fix nitrogen, to make plants grow at room temperature. And how does that molecule work? That allows us to fix nitrogen and make fertilizer, not using 1% of the world's energy, but at room temperature. Nobody knows. And there's not a computer on earth that can solve that problem. So one example done by a group of people from Microsoft is to study this particular problem, biological nitrogen fixation, using this molecule called nitrogenase, and ask the question, if we had a quantum computer that was working with all of these simultaneous states unmeasured, using algorithms that are different from classical algorithms, and could take advantage of quantum computer algorithms, you'd only need a small working quantum computer to get it to work. How small? Well, you'd need a few million bits, but, you know, compared to the stuff that's in most of your hands right now, that's not very hard. Oh, it's true. those bits have to be unmeasured until the computation is done. That's a little bit harder in what I'll tell you about next. But with a few million or a few tens of millions of these bits, you could solve chemistry problems in ways that we can't now, and that the computers don't scale to solve. Here's another interesting example. This is a magnetic levitation train that has been tested in Japan, and it uses superconducting magnets to elevate the train. The superconducting magnets need liquid nitrogen, liquid helium, excuse me, and wouldn't it be nice if there was a material that superconducted not at such low temperatures, so we didn't have to fill the train with liquid helium? Shown on the other side is a bottle of magnesium diboride. For 50 years, you could just buy this stuff from the Alpha Aesar company or any other company, and you'd put it on your shelf, and nobody had done anything about it. Until people one day took this stuff right off the shelf of their laboratories, and discovered that it was a 30-degree superconductor. They'd never tried it before. I mean, you can't go to every chemical on your shelf and find out if it's a superconductor. So no one had ever tried it. You'd think, why can't you just calculate it? Just figure out whether magnesium diboride is a superconductor or not. There's no computer on Earth that can solve that problem. Nor is there a computer on Earth that can solve the problem of, is there in existence one that conducts free of dissipation at room temperature? Nobody knows. So there is a need for a technology beyond not just faster than what we've got and not just needing better software, but beyond the capacity of our current paradigm for computation. There are many groups trying different techniques to make such a machine using either atoms, which have multiple states that can operate as bits, superconductors in which current can flow clockwise or counterclockwise, acting as a bit, or electrons in which the magnetic moment, the spin of the electron, behaves as the bit, up or down, corresponding to 0 or 1, and it remains unmeasured. I want to tell you about Microsoft's approach to the problem. It's taking a different way of approaching the problem, whereas many of the approaches to quantum computing take existing technologies in laboratories today and say, can I make a quantum computer out of this thing which I've already been working on for 25 years? It seems like a pretty good candidate. Microsoft started at a different place, which was to ask the question, what would one need in order to actually make this thing work? And an interesting idea was arrived at, which is, I said that things didn't become measured until they interacted with the environment, or until they hit the screen, if you want to say it that way. Now look at this knot. Where would you measure, if you could do a local measurement on the knot, to find out whether or not it was tied in a knot or not? Sorry about that. I'm sure it's better in Swedish. And the answer is nowhere. You can't look at a spot of that knot and find out where it's tied. You have to somehow stand back and look at the global structure. Imagine if there were a particle in nature that you could wrap one particle around another, like tie it in a knot, and it would remember. Then you could imagine making a computer out of knots, and local measurement by the environment would not remove the quantum superposition of states. It's a fantastic idea, except it seems that those particles don't exist. That did not slow down the mathematicians and the theorists from proposing a machine made out of particles that could be tied in knots, and invented the field. Here, Mike Friedman from Microsoft, as one of the founding inventors of this technology, called topological quantum computing. Now, this notion of topological particles, in fact, became so popular and so interesting that it was the subject of the 2016 Nobel Prize in Physics. If I read to you from the bottom, topological insulators, insulators in which there's a knot structure or a complex structure, topological superconductors, topological metals. I'll let you read the rest of it for yourself, but what you see at the bottom line is that these are useful for a new generation of electronics and superconductors, or possibly future quantum computers. That's the subject that I'm talking about. Can you tie particles in a knot? Microsoft started from a funny perspective, which was rather than looking at the technologies that existed, they asked, what do we wish existed? And then sent us experimentalists on our merry way to go find them. And lo and behold, there is a place where possibly you can find them. Here, when you combine a one-dimensional wire with a superconductor, you can produce an excitation that has never existed before when those two materials had never been put together before. And at the end, in those red balls shown at the end, are excitations that can be tied in a knot. Where do you get these materials? You have to grow them. They grow inside of a molecular beam epitaxy machine that grows these materials, and they produce these long, skinny wires. And 1 year after those ideas were put together, our friend Leo Kouwenhoven, now at Delft University and Microsoft, put those ingredients together just as the theoretical physicists said to, and found that little bump that you see in the middle of the graph. That little bump was the predicted signature. 2 years later, a materials scientist named Peter Krogstrup, also at Microsoft now, invented something that the world has never seen. And if you haven't seen this picture before, you should be shocked. This is a semiconductor, the basis of chips, grown epitaxially on top of a superconductor. Now when you make these devices and compare the theory and the experiment, they're dead ringers. Now we start the problem of trying to build a quantum computer, now that we have the particles that you can tie in a knot. And you better believe it gets complicated. These all live inside of refrigerators down at base temperature, and that's about 10 millidegrees above absolute zero. And finally, I want to emphasize, this is a hard problem. This takes not only a team around the world, but it takes the support of Microsoft all the way to the top. With new centers like this quantum laboratory that exist now in Copenhagen, and a global effort to try to build a machine that the world has never seen. Thanks.
Vad härligt. Ja.
Tack så mycket.
Ja, detsamma Therese och Daniel. Det var kul att jag fick vara närvarande här och sprida lite magi. Så. Och vi ska väl börja avrunda lite smått för att ta oss ut i sessioner och liknande här. Så jag tänkte att nu har ni ju suttit en liten stund, så jag tänker att vi tar och stretchar på oss lite grann, som alla här inne bara kan sträcka ut händerna på det här sättet. Passa grannen, snacka bara lite snyggt och tummarna ner mot golvet på det sättet och fladdra över med höger hand ovanför vänster, bara så. Och knip ihop lite snyggt så. Jättebra där.
Vi vet inte vad
stretcha upp lite grann. Här kommer du få plats med mycket kaffe. Och ner lite så. Och när ni kommer precis här någonstans så vrider ni sakta till höger så ni får upp bägge tummarna på det här sättet. Här kan man vinna en skoter om man har tur. Ja, jag tror jag tappar alla, men det är ingen fara. Det var precis det som var meningen. Jag skulle vilja prova en sista sak här. Så skulle ni kunna hjälpa mig? Jag kommer att kasta ut den här bollen i publiken. Om ni kan gå ner och ta en mikrofon ska vi få höra. Så det blir lite random sådär. Så jag tar den här och bara kastar ut den till någon som fångar den precis där. Har vi någon? Vad härligt. Och vad heter du?
Jag heter Daniel Stengård.
Daniel, har du och jag någonsin träffats tidigare?
Det kan jag inte tänka mig.
Nej, och jag har inte ringt upp dig och bett dig liksom, om en tjänst eller du får 5 000 spänn om du säger det här eller det här. Nej. Men Daniel, om du bara helt random från ingenstans skulle nämna ett namn, vad skulle falla i din smak?
Sara.
Sara. Daniel, Sara. Härligt. Daniel, skulle du kunna ställa dig upp, är du snäll? Och så sen kastar du bollen lite snyggt bara åt det hållet någonstans. Ja, däråt. Så att det blir lätt för Therese eller Daniel. Där har vi en. Härligt. Om du tar dig ut i mittgången, min herre. Och Daniel, du kan stå upp. Härligt, tack för hjälpen. Vad heter du?
Andreas.
Andreas, om du från ingenstans bara skulle nämna ett tal mellan 1 och 1000, vad skulle du säga då?
17.
17. Lucky number? Ja, härligt. Skulle du vara snäll och kasta bollen åt det hållet? Där, ja, precis. Och där har vi någon person som precis där blev träffad i skägg. Härligt. Vill du vara snäll och ta dig ut i mittgången också? Andreas, jag vill behålla dig också. Om du bara står i mittgången, jag är lite besvärlig här. Så får vi en person till. Och då har vi Anders. Härligt. Anders, har du varit ute och rest någonting på senaste tiden utomlands? Ja. Nu vill jag inte att du nämner det landet, men jag skulle vilja att du bara tar ett land som kommer till dig från ingenstans här och nu. Vad har du för land som dyker upp i ditt huvud? Italien. Bra val. Italien tycker vi hemskt mycket om. Så. Hörrni, nu vill jag tacka moderatorn för er hjälp, så syns vi lite snart. Och ni tre som står här, vill ni vara snälla och komma upp på scenen, får ni enorma applåder. Hej, välkommen. Hej, härligt. Morgonpigga, hej. Härligt. Hörrni, jag har en liten ask här. Och det är 5 stycken tärningar. Och det är 5 olika färger. Det är röd, svart, gul, vit och blå. Och jag skulle vilja att ni bara ställer upp på en liten rad här. Så ska vi testa lite kroppsläsning och intuition. Så om du tar en tärning utan att visa varken dina kompisar eller de här ute och gömmer den i handen. Bara ta en och så skickar du den vidare. Och när sista man har tagit en tärning så kan du bara lägga ner, stänga locket och lägga ner. Okej. Är ni klara? Ja, härligt. Jag tänkte vi skulle leka en liten lek, bara testa sådär. Har ni lekt den här, du vet, när man gömmer någonting bakom ryggen och så sen sträcker man fram händerna och så ska man gissa var tärningen är. Jag skulle vilja börja med dig. Om du bara blandar runt den här tärningen du har och sträcker fram bägge händerna och tar fram ditt värsta pokerface. Här ser ni värsta pokerfacet. Så jag bara lyfter upp handen så. Och eftersom din näsa pekar på den handen, vilket man ofta har en tendens till att göra, nu vred du om lite grann där, så snyggt ja, härligt. Ja. Så skulle jag säga, i den handen så ligger en tärning, kommer rätt snabbt. Och på något sätt så känns det som att i den här handen så ligger det inte en röd, inte en blå, men åt det hållet lite mörkare. Jag skulle säga att det ligger en svart tärning i den handen, så om du öppnar den handen ska vi se, där i har vi en svart tärning. Som ett litet tips. Om ni skulle leka den här leken någon gång, näsan har en tendens att peka på det ställe där saken ligger. Vi provar en gång till. Värsta pokerface. Blanda om, sträcker fram, kommer ihåg näsan. Och du har du nästan glömt av den där. Kolla, den är enkel, eller hur? Så om jag separerar dina händer här och tittar dig djupt in i ögonen så, och jag försöker ta den här åt det hållet. Ser ni vad som händer? Det är lite svårt. Sen är det så också faktiskt, om jag känner på den handen så känns den mycket lösare än den här handen. Det är till och med man ser det. Så att jag tror att du försöker lura mig genom att hålla den lite lösare, genom att där i den lösa handen så har jag absolut inget objekt. Så därför går jag på den här, eftersom du precis nu också inte tänker rött, nej. Men kanske blått. Nej, du är åt ett helt annat. Och jag skulle säga att i den här handen så ligger det en vit tärning. Om du öppnar upp den handen ska vi kolla. Så ligger en vit tärning där. Wow! Bra jobbat! Näsa, hårda, lösa händer. Här har vi killen som spelar mycket poker. Inte en min. Och du bara blandar runt, sticker fram. Vem vill köpa en bil av honom där? Det här är cool. Maestro. Det spelar ingen roll att jag gör så. Din näsa följer absolut inte med. Så här är helt omöjligt också, eller hur? Stoneface. Ser ni att en axel är lite högre än den andra? Det här låter korkat, men det är faktiskt så. Anspänningen av att hålla upp någonting har ibland en tendens. Så om jag skulle rätta till den här lite grann, så. Så i den handen, för nu börjar du bli lite trött, eller hur? Så att du börjar darra. Nej, är det så? Jag håller på att fiska, jag har nämligen ingen aning. Men jag har en känsla av att den ligger här. Och jag har en känsla av att det absolut inte är svart och vit, för i så fall skulle det bli väldigt förvirrande. Jag skulle säga att i den här ligger en av dina favoritfärger. Kanske den färg som din byxa har. Jag skulle säga att det ligger en blå i den handen. Om du öppnar upp den ska vi se. Jajamensan. Härligt! Wow! Superduktiga! Men nu innan jag släpper iväg er, jag hade en liten dröm. Och det är så här, när jag vaknade upp i morse, lite lätt förvirrad som man kan vara på morgonen, så hade jag en liten dröm som jag skrev ner. Och jag skulle vilja visa er någonting här. Det ser ut så här. I den här lådan så har jag en liten rulle. Och i den här så ligger det några papperslappar. Eller egentligen bara en. Och jag hade en sån där känsla av att kanske är det min lucky day, eftersom det är ett så speciellt event. En så magisk känsla just runt den här dagen. Så jag skrev 3 saker. Jag skrev Sara, 17 och Italien. Ja. Så kan det vara. Jag tar en tärningen. Ja, tack så mycket. Mina herrar, ett sant nöje. Tack. Ge dem jättevarma applåder. Varsågod, ta plats. Bara softa. Ja.
Ja, det är ju lite spännande. Inte bara med tekniken, utan tekniken är väl det som kan skapa lite magi också för oss. Men nu har vi börjat komma in på slutskedet, eller början kanske.
Ja, nu är det ju dags. Och nu är det dags faktiskt att ta sig an de här 2 dagarna. Och det finns otroligt många sessioner att välja. Vi har 105 olika sessioner att välja. Och har du inte laddat ner den här appen så gör det. I den så skapar du ditt eget schema. Du har info om hur du gör för att vinna en Surface Go, och det vill ni väl göra. Och det är också där som ni utvärderar sessionerna, och vilket gör att vi kan kora en vinnare. Och tänk också på det nya formatet Microsoft Tech Talks som vi kommer att köra nere i Microsofts Montus med ett lite annorlunda format med kortare sessioner om man är intresserad av det.
Och missa inte heller vår partnerutställning där ni också kan möta vår Magic Mirror som bland annat då Hennes & Mauritz har använt på sin eller skyltfönsterbutik i Times Square. Så där tycker jag att ni ska göra ett litet besök och klappa och prata med den. Sedan så har vi också minglet som kickar igång 6:30 ikväll. Missa inte det, och det blir också lite musik från Ferillos, och jag tror Daniel att vi faktiskt är dags att säga hej då. Eller vad säger vi då?
Säger
nu kör vi!
This is Tech Days.